Welcome. In this lesson, we continue talking about inheritance by looking at the very important topic of overriding methods. Let's get started. We've got three learning goals for today. The first is that you need to be able to override an inherited method in Java and explain the need for overriding. You also need to be able to use the @override compiler directive, and finally, be able to explain how the visibility modifiers, private and public, impact inheritance relationships. Remember from our previous lessons that inheritance is a relationship where one class inherits the variables and methods of another. In this case, we have a person superclass and a student subclass, and the student has a GPA and a schedule, but it also inherits the name and the birthday from the person. To begin this lesson, we're going to take a look at the person class. Now remember that that's the superclass. And what we'd like to do is we'd like to add a toString method to it. Recall that in a class, the toString method's job is to return a string version of the object, and we can define that however we want. So in this case, I have a public method, and I need it to be public so I can call it from the outside. It's going to return a string, and the method name is toString. And all I do is I return the person's name and birthday, and I label those name and DOB, which is date of birth. The toString method is special because it gets automatically called when we printline an object. So in the sample code here, I've created a new person P, and then I printline that person, and that results simply in the following output. It calls the toString returns the result, and the result gets printed by the print line. Now let's turn our attention to the subclass, the student class, and I do the same thing. Notice that I make a new student object called S, and I set it to a new student with the same name and birth date, but I also specify the grade point average and the student's schedule, and then I print line the student. Now, the student class does not have a toString, but because we have an inheritance relationship, it does inherit the toString of the superclass, and so we get the exact same result because that toString method returns a string containing the name and the birth date. It's actually pretty great that the student class, in a sense, automatically has a toString method, and I didn't even have to write it because of this whole inheritance thing. But what if the toString method that I inherited wasn't quite what I wanted? I mean, it's great that the name and the birthday show up, but what if I also wanted the student's schedule and GPA to show up? These are things that are specific to the subclass, specific to the student. How could I do that? And this is where the concept of overriding is going to be very, very helpful to us. Method overriding is actually a fairly simple concept, and it has three characteristics. The first is that we have a method in our superclass. And the second is that a subclass creates its own version of this method with the exact same method header, which means name, return type, and parameters. So the superclass has a method, and the subclass has its own version of that exact same method. And then, when the method is called on a subclass object, the version in the subclass overrides the inherited method. Now that was kind of a mouthful, so let's see it in action. Previously, we wrote that toString method in the superclass, person. And now we turn our attention to the subclass student, where you will notice that I also have created a toString method. And this is the exact same method, public string, toString with no parameters, exactly the same as we saw in the person class. But this version of the toString method is going to perform the task a bit differently. Notice in this case, I'm returning the student's schedule and their GPA, where previously in the superclass, I was returning the name and the date of birth. Now we revisit the code we looked at previously, where we create a student object S and we print line that object. Now we know the toString method is going to be called, and before it called the toString method of the superclass because it was inherited. Now we've overridden it. We've created our own version of toString in the subclass, and the result is that that method gets called instead of the one in the superclass. And you can see it now displays the schedule and the GPA. In general, overriding occurs when we have a method in the superclass that is identical to a method in the subclass. We can see that here. In the superclass, we have a toString method, and in the subclass, we have the exact same toString method. So the subclass is overriding. So when we call the method, in this case toString, Java will first look in the subclass for the method signature. If it's found, it executes the method. Otherwise, it will go up and check the superclass and execute the method there. Of course, if it doesn't find it there, that's just an error because you're calling a method that doesn't exist. When we're overriding methods, we don't always want to totally replace the inherited method. Sometimes we just want to add on to it. For example, in our student subclass, we overrode the toString method because we wanted the specific information of the schedule and the GPA to show up. But that doesn't mean we don't want the information we had previously, which was the name and date of birth. And so we need to figure out how to get both of those together without having to duplicate a bunch of code. A really handy way to do this is to use the super reference, which we first saw in the previous lesson when we were talking about constructors. Super is used anytime you want to talk about the superclass. And so if you look, the first move I make is I make a call to the superclass toString. So I start with string result equals super.toString. So result is going to actually hold a string containing the name and the date of birth because that's what the superclass toString produces. And then my code adds on to that the schedule and GPA and returns the result. And by doing this, both toString methods get called because the subclass method calls the superclass method, and now we have an output, a result that combines both the original toString method and the overridden one, and we didn't have to double up on the code. When you do override methods in Java, it can be really easy to make a mistake. After all, the method header, which is the return type, the method name, and the parameters, all need to match exactly. And it turns out that Java can check your work for you with the @override compiler directive. How you use this is extremely simple. All you do is right above your method header, you say @override. And if you put that there, Java is just going to automatically check to make sure you are overriding the method correctly. And if you're not, it gives you an error message. So it's not required, but it's a useful tool if you want Java to catch that mistake for you when you make it. Before we wrap up our discussion on overriding, we need to talk just briefly about the public and private visibility modifiers and how those might impact inheritance. So perhaps I would like to take a more direct approach to my toString method. Maybe I don't want to mess around with the super call, so why not just access the variables directly? Now you'll notice I've simplified the toString method by removing the formatting, and that's really just for the purposes of this explanation. So maybe I don't call super. Maybe I just say, hey, I just want to return the name, it's inherited. I want to return the birthday, it's inherited. And I want to add on to that the schedule and the GPA, which of course are our instance variables in the student class. Why not just do that? Unfortunately, this doesn't work. And the reason it doesn't work is that even though the variables are inherited, name and birthday, they are still private. And because they're private, they're still not directly accessible outside of their class. We have inheritance, we're inheriting values, but encapsulation, the idea of protecting the instance variables of a class, is still a thing, and it's still going to be enforced. So this isn't going to work at all. And this means that the only way to access these inherited values is through things that are public. And there's a couple of ways to do that. One of them is that we could call the inherited getter methods. Remember, not only do we inherit the variables, we inherit the methods, and the getters are public, so we can call those and access the name and the birthday that way. The other option is to continue using the call to super.toString as we saw previously. The point is, when we want to access those inherited values, we have to do it through things that are public. Private is still a thing, and so even though I'm inheriting from the person class, the things that are private in the person class are still not accessible to the outside world. So I have access to the public getter methods, I have access to the public toString, but I don't have access to the values themselves directly. All right, time for a quick understanding check. On the left and the right, I have two almost identical student classes. Remember, these are the subclasses. There's only one ever so slight difference between them. And I'd like you to identify that difference and also explain why it matters. Why is it important? So pause the video, and when you're ready, we'll chat about the answer. So the difference between these two is the word super. On the left, we have super.toString, and we already know that that means that we want to call the toString method in the super class. On the right, we omit super.dot. And technically, this is still legal code, like it will probably run, but it doesn't do what we want. Because since we don't have the super dot, when we say toString, it's going to look for a toString method right here in this class, and it's going to find one. Basically, this is telling the method to call itself. And so that's going to be a problem because it's not going to give us the result we want. It actually will create what's called infinite recursion, which will be a topic that we cover in the next unit. At this point, you should now be able to override inherited methods in Java, use the @override compiler directive, and explain how visibility modifiers, private and public, can impact inheritance relationships. It's worth noting that the example from this lesson, the toString method, is just one example of overriding, but it could apply or be used on any method. It's not something that's just special to the toString.